Acceleration is the differentiation of the velocity, rate of change of velocity. So we can find the acceleration by differentiating the velocity, which is given as a omega cos omega t. So acceleration, which can be written as y double dot d by dt of v, that is d by dt of a omega cos omega t. Alright, the acceleration will be a omega will be constant. Now differentiation of cos will be minus sine of angle omega t, and to differentiation of omega t, which is the angle, that will be omega. So we have will be minus this omega, and this omega will be omega square a sine of omega t. But if you see y is a sine of omega t, so acceleration, that is y double dot, which is equal to minus omega square, this term I have written as y. So acceleration is minus omega square times y. So acceleration is proportional to displacement, negative times displacement. So here we can give the definition of the simple harmonic motion. We can say that a particle is executing simple harmonic motion if it moves to and fro about the mean position such that its acceleration is proportional to y at any instance of time. But the direction of the acceleration and the displacement are opposite in direction. These are opposite in direction. So here, as the particle is accelerating upwards, then displacement of particle will be negative times y. So from this definition we get that any particles having simple harmonic motion, if it moves to and fro about mean position such that acceleration is negative times displacement. This is the definition of simple harmonic motion. Phase. Phase specifies the location of an oscillating particle at any instance of time with respect to its mean position. So phase gives me the position of the particle while it is moving at any instance of the time with respect to origin. As we have seen that, suppose the particle at t is equal to 0 is at this point, and now from after time t it moves up to p. Now after time t, what will be the angle? The angle will be the theta. So here we know that displacement of the particle is a sine of theta or a sine of omega t. As you know that omega is 2 pi over t. Omega, it is actually when particle moves in one complete circle, it has 2 pi radians. And it takes time t seconds, that is time period of the oscillation, time taken by a particle to complete one oscillation. So, omega is 2 pi by t. So we have y is equal to a sine of 2 pi t. This angle 2 pi t is the position of the particle, which is measured either in terms of radians, or either in terms of angle, or in terms of time. And this term 2 pi t is known as phase. Phase angle, or simply this is known as the phase. This angle gives me the position of the particle when it is moving in a circular path. Now what is phase difference? Phase difference. Let's consider this particle at p when t is 0, and after t it moves to t. Initially it is at angle phi. Initially this is at phi when t is 0. Now from p it moves to q, making angle theta. So what is the displacement? Here we have a different angle. If you draw q and perpendicular, you will see here you will see it there that this angle will be theta, this is phi. On total this will be theta plus phi. That means we have y dash a sine of theta plus phi. Theta, as you know, this omega t, so y dash is equal to a sine of omega t plus phi. Alright, so we have two particles moving in this circle and this circle. The displacement of the particle at any instance is y a sine of omega t, and another particle a sine of omega t plus phi. Phase of the first particle is omega t and phase of the second particle is omega t plus phi. So difference between phase angles. Difference between phase angles, that is omega t plus phi minus omega t, that is phi. This is known as phase difference. The particles lag behind the phase angle of phi. See the particles, the projection of two particles which are in the circular motion with constant velocity. Their difference in angles is phi. That is why one lag behind the other way angle phi. Thank you.